Hello everyone, in this video I'll be explaining you the problem Grid MEX and it was asked in starter 199 of Codechef. So let's read out the problem. I think the fourth one was easy problem. I think because the constant was very less and was 30, that's why. So if the constant was like big, so it would have been a bit challenging. So since it is division 3, so usually we understand it is constant will be less. So yeah, let's read out the problem. You're given an integer n, construct n cross n grid, that is n rows and n columns filled with n square integers. So return a of I comma j, represent the element at the ith row in this column. Define v of I with a set of all elements x comma y such that exactly one of x is equal to I and y is equal to I holds. In other words, v of I comma j is the set of all elements in the same row or column excluding I comma j itself. So yeah, the grid must satisfy the following condition. The element what we are finding, it should be greater than equals to 0, less than equals to n square, and a of I comma j is basically mix of this set v of I comma j. So what is mix operation? I'll be telling you, don't worry. So it can be proved that a valid grid always exists. Find any valid grid. So yeah, so first let me take the test cases. Entity we have, and we'll run a while loop in order to take care of all the test cases. For every test case, we'll call a function solve, and its return type is integer, does not have any parameter, and for every test case we have integer n. So let's try to understand examples. So sorry my bad, I have not cleaned my board. So yeah, let's understand. So what they're saying is they'll give integer n. So you will have to find n cross n matrix where this array element is I comma j. This element, how do you find it? So you will have to find the MEX of a comma j, sorry, MEX of v comma I comma j will be a of I comma j. What is this MEX operation? MEX operation usually starts from MEX number usually start from 0, 1, 2 up to so on infinity. It's like 0 to infinity, and it is applied to one of the subsets or variables or string you can think of. So v of I is a subset, set we can say, or subset. Let's say we are calling it a set. Let's say v of I has element 1, 3, 5 we have. So if you try to think of like 0, if you try to find 0 is not there, so mix of this set is basically 0. Now let's take other example. We have 0, 2, 3 we have. So now if you try to think of 0 is there in this case, and next element will be 1. So 1 if you try to find it is not there, so your max of this 0 to 3 is 1. So max operation is basically that integer, smallest integer which is not present in the given set, and it is non-negative integer. Non-negative means it starts from 0. So let's try to find 1, 2, 3. If we have this set, so its max operation will be 4. Why 4? Because it starts from 0. 0 is there in the set. Next we'll go to one element which is also there. Next we'll go to 2 which is also there. Next we'll go to 3 which is also there. So 4 is not there. So this is the non-negative integer, least non-negative integer which is not there in the set. So that is max operation. I think you guys got to know. So what they're saying is this v of ij will be, let's say you have defined a subset and this element is a of I comma j. So whatever elements we have, let's say it is n is 4. So whatever element we have, let's say here 0, 1, 3, 4, 5, 6, something we have. So for this a of I comma j, you will have to take all the elements in a set. So we are taking 0, 1, 4 we have. Now let's take 3, 5, 6 also. 3, 5, 6. All the column elements, all the row elements of this particular aij. So now this is one of the subset. In this, if you try to find MEX operation, what is that? 0 is there, 1 is there, 2 is not there. So your this cell will be filled with 2. I think you guys are getting right. So now let's say you have all the elements as 0, 1, 1. So now if you want to find here what will be the element, so put this element in a set. So it starts from 0 MEX element, which is not there, so your element will be here 0 only. So I think you guys are getting how to do it. So given an example where n is 1, when n is 1, obviously your matrix will be 1 cross 1, just one element, and since there is no row, no column, so your set is empty basically. So your MEX operation always starts with 0. Now you try to find 0 in the set, we don't have, so you just put it. So for n is equal to 1, you have this as one of the array. So now let's try to find for n is equal to 2. For n is equal to 2, what you will do is, let me try to put in this way. So we will like start iterating from left to right. Okay, from left to right, and when we reach the end of the column, we'll move to the next row. Here we'll move it, and again we'll start from left to right. Why I'm doing this is that, so whatever element you'll be putting here, okay, depends on what elements is there in the column, upper column, and whatever element is the left side of the row. So whichever element is not there in these two columns, so that will be in setting, right? So just now what I showed was for you is like you have 0, 1, 1. So when you are finding element MEX operation of this, basically what element you will have to put here. So what we'll be doing is all the column elements you'll be putting in a set, all the row elements you will be putting in a set. Okay, and set will contain only one element. So like one element means unique element it will contain. So you have one, and when you are found all the column and row elements, you have put it here. So now you will try to find the MEX operation, which starts from 0. So 0 is not there, you will be inserting 0. So now let's say your array is 4 cross 4, and somehow you have filled here all the, like, first you'll be filling it as 0 element because no column is there, no row is there, so MEX operation is 0, you'll be putting. When you come at this cell, you don't have upper column, but you have left side row which has 0 in the set, but its MEX operation it will be 1 because 0 is there, so 1 is not there, you will be putting as 1. Again, when you're trying to find the element of this cell, what you'll be doing is, you don't have column, you have row. In row you will be inserting 0 and 1 because these two elements are there, so its MEX operation will be 2, so you will be putting here it as 2. Now in the same way this will be 3. So I think you guys are getting, like, in column we don't have any element, but in row we have 0, 1, 2, and MEX starts with 0, 0 is there, 1 also is there, 2 also is there, 3 is not there, that's why I'm putting it here. Now I am trying to find the element of this one. I'll be checking its column. 0 is there, I'll be putting in a set, 0 we have. Okay, and do we have any row elements in the left side? We don't have. So MEX operation of 0 will be 1, right? Basically I'm finding this for n is equal to 4, and in the question they have confused you, like they have given 1, 1, 0, 0 for n is equal to 2, just to confuse you. But when you basically try to find the whatever method what I'm saying to you, when n is equal to 2, you start with 0 here because you don't have any element, set is empty, so you'll be inserting 0. Here you'll be inserting 1, here since I have 0 you'll be inserting 1, here set will have 1, 1, 0 is not there, you'll be inserting 0, so this will also pass. So I think in this way you can solve it. Now at this position you are finding you have 1, 1 in the set, but 0 is not there, so next start with 0, you'll be putting 0. So I think you guys are pretty much getting. So if you want to put element here, so I think it will be 2 is there in the set, 0 is there in the set, 1 also is there in the set. So next number what is not there, next non-negativity which is 3. Now if you want to find here, we have 0, we have 1, and 2 is not there, so you'll be inserting 2, right? So yeah, in this way we'll have to do it. Here it will be 2, and here it will be 0, we have 1, we have 2, we have, so it will be 3. At this position it is like 2 we have, 3 have, 0 is not there, so it will be 0 here. And I mean this position 0 we have, 1 is not there, you will be inserting 1. Like above you are checking and this side you are checking. So based on the above column and left side row, whatever elements are there that you are putting in a set, and MEX operation will start from 0, you are checking if that element is there or not. If it's not there, so you will be inserting. So in this case 0 we have, 1 we have, 2 we have, 3 is not there, you will be inserting. This one you are trying to find, so above we have 0, 1 we have, 2 is not there, so you will be inserting 2. So I think MEX, I'm repeatedly telling you, MEX is a non-negative integer, it starts from 0. So in this case 0 is there, 1 is not there, so 1 here also is not there, here also it is not there, so you will be inserting 1. And at this position, see 0 we don't have, so you will be inserting 0. So for n is equal to 4, this is your grid matrix required. So I think you guys got how to do it. Since n is very small, so I'll be doing it in a brute force way only. So what I'll be doing is I'll be taking a vector, let me go call v, its size is n, okay. And now I'll be taking 2 loops, because for every I comma j we'll have to find the element of that grid. So okay, so here what I was doing, for every particular cell I was going upside and left side. Upside in the column I was going. So let me take one set, unordered set of type int, let me call st. Now I will go to the column wise, will go up. So column I'll be representing with j index. So yeah, sorry, j is already there, so I'll represent with k index. Upside how will go? All the upside elements, it start from I minus 1, right? It start from I minus 1, and your k has to be greater than equal to 0, because you're going to the 0th position, k minus minus. So st dot insert, what you'll be inserting, you'll be inserting basically your since you're going upside, rows are changing. So first index in v is basically row, which is k, and j is same because column is same. Now we will iterate to the left side, which means row is same, column wise you're going backside. So when you're going column wise backside, so it will start from j minus 1, j greater than equal to 0, j minus minus. I think you guys are getting right. st dot insert, since you are going column wise, your row is constant, which is I, and we have k. Once you have filled all the elements from this a of I comma j, whatever elements were there at the up and whatever elements were there at the left side, you have filled it, you will take int MEX, which will be initialized with 0, and you will find st dot find of MEX. If it is not equals to st dot end, which means in this set that MEX is there element, so you will increase MEX by 1 and try to find it. So whenever you the MEX value is not found in the set, so that is the least non-negative integer, which is our a of I j value. So in case of a, I'm just taking here v, so don't worry. So here MEX we have, and let when we are coming out of this loop, we'll be just displaying our answer. We could have displayed in the same loop only, but to make this code readable, I'm just taking one more extra loop. So you'll have to display v of I comma j with the spaces, and once you display one row, in order to display in another row, you will be taking endl. So yeah, let's try to run the code. So we will be expecting 0 and 1 0 0 1. So what happened to this? Time limit exceeded. Okay, here I missed something. Okay, my bad. See, I'm dealing with k integer, but I'm decreasing j. So here I've missed it. So we are getting 0 0 1 1 0. This is also a valid matrix. This is also valid matrix. Just to confuse you, they have given 1 0. So but if you try to think of in MEX way, this also holds correct for MEX. If you try to think of right side, if you see, we have 0, downside we have 0. Okay, so the next operation, I mean in MEX you have number is 1. So this is also correct, but we will be dealing with the serial manner. Upside will be checking and left side will be checking. So let's try to submit the code. So yeah, it got accepted and it is correct. Since test case is very small, so brute force got accepted. So yeah, thank you guys for watching the video.